Alright, so today we're going to continue our conversation about solving systems by elimination, but today we're going to talk about a multi-step approach rather than a one-step. So let's go through the steps that we would use to solve a system using elimination. Alright, so they're going to be pretty similar to last time, but this will be a good review. So the first step is to multiply the equations by a number so that the coefficients of one variable are opposites. So last time, we just had to make sure that our coefficients were opposites, but this time, we might have to do a little manipulating by multiplying to make sure that they are. Our second step will be to add or subtract our equations. So one variable in the end should be eliminated. So that's similar to last time. And our third step is to solve for the remaining variable. So whichever one was not eliminated, we'll solve for. And our final step is to plug in the solution from step 3. So plug in our solution from step 3 into one of the equations to solve for the other variable. Alright, let's do some examples. Okay, so our first example, we have a system with 8x minus 2y equals 12 and negative 4x minus 3y equals 2. So if we examine this right away, we can see that none of our coefficients are opposites of one another. 8 and negative 4 and negative 2 and negative 3. So we're going to have to do a little manipulation to make that happen. So our first line of business is to identify which variable would be easier to eliminate. So when I look at this, I notice that 4 is half of 8. So when I multiply negative 4 times 2, I get something that cancels with 8. So let's do that. Let's multiply, and we're going to multiply this entire equation by 2. And what I'll get, I'll rewrite down here. So I'll have my system, and my first equation is 8x minus 2y equals 12. And my new multiplied by 2 equation is negative 8x minus 6y equals 4. And I want to make sure before I do anything that all of my variables are lined up, my equal signs are lined up, and now I can add these two equations so that my x's cancel. So I will add them up, and I'll find 8 plus negative 8 is 0x, negative 2y plus negative 6y is negative 8y, equals 12 plus 4 is 16. So 0x is just 0, and I have negative 8y equals 16. Divide that by negative 8 on both sides, and y equals negative 2. So I have one of my variables solved for, and now I can plug this into either equation. You can choose which one you like. I'm just going to do the first one, so let's carry that over here. I have 8x minus 2y equals 12, and now I'm going to plug in what I know about y. So I'll get 8x minus 2 times negative 2 equals 12. And this equals 8x minus 2 times negative 2 is a positive 4 equals 12. And I subtract 4 from both sides, and I get 8x equals 8. Divide that by 8 on both sides, and x equals 1. Now, my solution is the ordered pair 1 comma negative 2. So 1, negative 2. And that is our answer. Okay, let's move on to a slightly different example. Alright, our second example, we have x plus 3y equals 7, and negative 4x minus 12y equals negative 28. So I'm going to also have to do a little manipulation here. And I see, well, if I multiply this first equation by 4, my x's are going to cancel. 4 plus negative 4. So let's do that. So I'm going to multiply this entire equation by 4. And I'll rewrite it down here. And I get 4x plus 12y equals 28. And my second equation stays the same. Negative 4x minus 12y equals negative 28. Okay, now I'm going to add my equations together. So I add both of them. Make sure everything's lined up before I do so. My x's, my y's, my equal sign. So my x's, I'm going to get 0x. 12 plus negative 12 for my y's is going to be plus 0y equals, and 28 plus negative 28 is 0. So 0x and 0y are just going to be 0. So I'll get 0 equals 0. Well, this doesn't tell me a whole lot about my variables. But it is true. 0 does equal 0. So that means that this problem has infinitely many solutions that make it true. So our answer is infinitely many solutions. Now, if you remember back to when we graphed equations and found their solutions, you'll remember that when we graphed lines, if two equations had infinitely many solutions, they ended up being the same line. They had points that fell on the exact same line as each other. So that's what we have here. If we were to graph these two, we'd find that they are indeed the same line. All right, let's do an example with a slightly different outcome. Okay, in our final example, we have x plus 4y equals negative 3, and 2x plus 8y equals 8. So in order to get things to cancel here, I might multiply this initial equation by 2. Because then when I subtract, which I can also do, we've been adding, but you can also subtract. When I subtract the second equation, my x's are going to cancel. So let's do that. So I'm going to multiply the first equation by 2. And I'll rewrite that down here. So I'm going to get 2x plus 8y equals negative 6. My second equation is going to stay the same. 2x plus 8y equals 8. And now I'm going to subtract these because I want these two x's to cancel. So I'm going to subtract. I'll find that I have 0x and then 8y minus 8y. So I'm going to get 0y equals negative 6 minus 8, which is negative 14. So 0x plus 0y is just 0, and I get 0 equals negative 14. Well, this also doesn't tell me anything about my variables, and this is not true. 0 is not equal to negative 14. So this means we have no solution. And if you remember before, in our last example, we had infinitely many solutions because the thing we ended up here with was true. We had 0 equals 0. But when it's not true, when we get two numbers that are not equal to each other, we get no solution. And if you remember what this looks like graphically, you'll remember that when we had no solution, it meant that we had two lines that were parallel to each other and never intersected. So if we were to graph these two lines, we'd see that they also were parallel. All right, so that's it for this video. You can go ahead and try those problems at the bottom of your guided notes. Thanks.